Good morning and welcome. The title of the talk is 10 Tips for Successful Creation of Contextualized Problems for Secondary School Students with Maple. My name is Matteo Sacchetta and I am a postdoctoral researcher at the University of Turin in Italy. The University of Turin was founded in 1404. Is one of the most ancient and most prestigious Italian universities. Hosting about 79,000 students, the University of Turin is today one of the largest Italian universities open to international research and training. It carries out scientific research and organizes courses in all disciplines except for engineering and architecture. In the University of Turin, there is a research group which is called the Delta Research Group. Delta stands for Digital Education for Teaching and Learning Advances. The group is coordinated by Professor Marina Marchisio, and I am part of this group. We work with different kinds of students, mainly upper secondary students and university students, to foster our approaches with education using technology, especially in STEM education. Going to the topic of this presentation, let's speak about mathematical problem solving. Students at all levels of schooling in all countries of the world need to practice mathematical problem solving to develop competencies that they will apply in real-life scenarios. Students thus need an education that explicitly focuses on this. When applying theoretical concepts, procedural fluency is an essential competence. On the other side, applying given mathematical procedures does not promote mathematical learning effectively, and there is evidence that it leads to rote learning, which is a common cause of learning difficulties. Thus, mathematics teaching should emphasize a deeper understanding of the subject and pay less attention to computation, rules and procedures, even though they play a non-trivial role. Critical thinking is an important skill too. How to activate the students? In a comparison with problem solving, problem posing refers to both the generation of new problems and the reformulation of given problems. Teaching mathematics from a problem-posing and problem-solving perspective entails more than solving no-routine problems or typical textbook-type problems. It is a way for students to exercise in all aspects of problem-solving, exploring, conjecturing, examining, testing, and generalizing. Tasks should be accessible and extend students' knowledge. Even students should formulate problems from given situation and create new problems by modifying the condition of a given problem. The quality of the problems submitted to students is an issue that needs to be carefully considered. There are different ways to apply good practices when designing a problem-solving activity with students. This presentation is based on my experience in creating problems for digital math training, a project whose aim is helping secondary school students to develop and strengthen mathematics and computer science skills through problem-solving activities using the advanced computing environment Maple. After a one-time training in the labs of the schools with the whole class, 3 students, the most skilled and motivated ones, participate in an online training. They are asked to solve a problem every 10 days and to submit a solution. In the meanwhile, students can participate in weekly synchronous tutoring on the use of Maple, and they can collaborate with their colleagues and peers through forum discussions. Students are then selected in an intermediate competition and the final one. The best students are awarded with a prize. In the slides you can see the final session of the digital math training in the previous years. Since they have to submit a problem, it is important to the question how to set up a problem. In this setting, you have to carefully plan and present the activity to the students. The text of the problem should be clear, concise, with little storytelling to enter into the setting of the problem. The problem should not be too theoretical, even if they could inspect specific aspects of the related theory, and need to be solved starting by simple requests until the most difficult ones, close to the edge of students' knowledge, and making use of a calculator, in our case Maple. We follow precise design principle in both the adoption of suitable practice and the use of Maple. These principles can be adapted to different situations. In the following slides, I will describe all these features with examples and provide useful tips according to the literature and according to my experience. The first tip is about brainstorming. Math is everywhere, in almost every facet of life. Galileo said that mathematics is the language with which God has written the universe. Most university degrees require mathematics. Mathematics influences our daily life, and teachers can use this information to enhance their ability to let students work on mathematical concepts. The starting point is the selection of the objective. Reaching the goal is the goal of the activity. For example, application of basic elements of combinatorics, or analysis of properties of mathematical functions, or interpretation of graphs. These are objectives. Usually, when searching for the right objective, I look at official guidelines, for example, the ones released by the Ministry of Education, at pedagogical theory, for example, Bloom's taxonomy of learning objectives, or looking at the 4 basic areas in mathematics: quantities, which is about numbers and algebra; space and shape, which is about geometry; change and relation, which is about functions and calculus; uncertainty, which is about probability and statistics. In the animation below, you can see an example of math that it's really everywhere. This is an animation of a person practicing hula hoop, seen from above, but it's just a matter, from a mathematical perspective, of circles and ellipses. After brainstorming, it's time to design your activity. You have to design it in detail in order to guide the students in reaching the objective. Think of all the details about your activity. Who is the target? What are the prerequisites? Will it be a group of individual activity or a mix of the two things? Which are the phases? How much time do you need for each phase? How are the users assessed? And in case of open-ended assessment, is there a rubric? Write down all these aspects to have it all in mind during the preparation of the activity, and make students aware of the most important things. For example, make them clearly know the assessment indicators. When you have to create an activity, storytelling plays a role to engage the students. The scenario of the activity, even if it is composed by short sentences, as usual in mathematics, can make students absorb the message from start to finish. The central message should be clear. Evidence the main question or the main concept. Use images to evoke emotional impact. You can use your personal experience to add value to the presentation of the activity, or add personal names to make it more close to the possible experience of students. Do not forget to fully describe the activity from the mathematical point of view. New or unclear concept should be shortly explained. You can guide the students with hints, but let them also try their own way to solve a problem. It could be a surprise. If the problem contains data, provide even useless data, so that students have to derive and select the most pertinent ones. I have personally used Maple random generation to create different and coherent datasets. For example, I generated random birthdays of students in different classes. The activity was to calculate in which cases two students have the same birthday. This is a known problem as the birthday problem. The relevance. Since the subject of the activity is a mathematical concept, it is surely used in a real context, because that is how mathematics was born, to be applied in a certain context. This context is probably one of the most suitable background for your activity. The data must then reflect reality, so it is important to select relevant values, close to the reality and not totally invented. Pay attention also to fully theoretical problems. They may be of interest only to a smaller audience of students. Divide the problem into multiple requests. This is called segmentation. It is better if the problem is presented in a user-pays segments, rather than as a continuous entity, in which it is easy to get stuck. Start with simple requests and increase the difficulty, for example, asking students to calculate a specific case, and then, after getting involved in the problem, they can start to model the situation. This will help not only as a segmentation activity, but to adapt to this question to the level of the students. In fact, about adapting to the level of the students, you have to push the students to go beyond their knowledge, to explore closed scenarios. In this way, even good students can be rewarded with intellectual engagement and challenge. They can check their ideas. An example in my experience, speaking of exploration, was the creation of an interactive tool to calculate the distance between two cities, given latitude and longitude of the two cities. Do not forget the use of technology. Most of the mathematics at school is done with paper and pen. But normally, every person uses some technology to manage mathematical problems. The most simple one is the calculator. Thus, it is better to create activities that require a calculator for their resolution. So, students need to calculate with difficult numbers, so that they can get used to the help of computing environments. And they try to give a proper input and interpret the output. About the use of Maple, I have a little focus on an activity with Maple. I personally suggest using the startup code to create simplified procedures that students can use while solving the problem. For example, to make some conversions from number to string, or to convert the time into different formats, or to have some standard plot that they can modify. In the example, parts of the visual application were previously prepared by the teacher in order to facilitate students' work and understanding of the main topic. This animation was about the children game, hide and seek, in which children have to count which one has to hide and which one has to seek. And this is a mathematical property. When they are in the circle, they are counted with some songs, and the animation shows which one is selected. Generalization. We usually use interactive components, or we request to build an interactive component to generalize the problem with different data and obtain the results according to the studied model. This lets students get used to providing the requested information to any user that is going to face a similar situation, but in a different context. The generalization can concern the parameters, the hypothesis of the model, or the number of mathematical entities involved, and so on. This boosts computational thinking skills in order to prepare these components. In the examples, on the left, students have to calculate an area about a theater. So the component just generalizes the parameters. On the right, there is a central point that students have to find, which is the point that minimizes the distances between the other points. It was presented as a problem in which many cities have to construct a sports center, a sport facility, which should be the closest to all the cities. Or, on the other hand, below, there is a component that calculates the last character of the fiscal code, the Italian fiscal code. There is a mathematical rule that allows every person to calculate this code. So, to summarize, we saw some tips that are useful for problem-solving activities. Brainstorming, design, storytelling, the description, the relevance to reality, the division into smaller problems, push the students to their limits, use the technology in a proper way. About Maple, make use of the startup code and let them generalize, let the students generalize the problem while using interactive components. These are part of our experience in problem-solving activities. They do not cover all the possible tips that can be said about problem-solving activities, but I hope that you enjoy this presentation and it will be useful for your teaching purposes or educational purposes with Maple. Thank you for your attention and thank you for your time watching this video.